welcome to a little video about the periods of sine and cosine functions. In order to graph and look at the periods of sine and cosine functions, we generally tend to use radians. Radians are just another way of measuring angles. And those are our little areas on the unit circle which have the pi's. The pi's over here. Now, the way we found radians is based on the fact that back in the day, we learned that circumference is 2 times pi times the radius. We learned it just in general in education, probably somewhere in middle school. We originally saw that equation, right? Now, we have a unit circle. The unit circle has a radius of 1, so 2 times pi times 1 is 2 pi. Therefore, the whole circle's circumference is 2 pi. I relate it right back to degrees. If we take a look here, we begin at 0 degrees, we go whole circle, end up at 360. This diagram didn't have it written down. I jotted it in. Same thing goes for our radians. We start at 0, we go full circle around, and we end at 2 pi. This diagram, once again, did not write 2 pi, and traditionally, and I feel like I've mentioned this before in previous lessons, that the start and stop point of a circle is the same spot. So when we look at a unit circle, we tend to just write the 0 for the beginning of the circle. Okay. Now, in our previous section, we learned that sine represents the y-coordinate on a unit circle, and cosine represents the x-coordinate. We're going to use that knowledge to graph sine and cosine. So let's try that out. Right. So in order to graph sine, we are going to look at all of the y-coordinates on our unit circle. Okay. And this is how I'm going to start. Now, first I'm going to start on the y-axis. This is 0. It's not written in there, but it's there. All right, so at 0 radians, what is sine? Well, let's check it out. I'm going to highlight sine in green. Okay. At 0 radians, right here, my y-coordinate is 0. Okie dokie. Let's plot that point. That's 0, 0. Ooh, I should use, if I did green, let's do green. Green. 0, 0. Okay, next, pi over 2. Let's check it out. At pi over 2, here it is. My y-coordinate is 1. How wonderful. Let's draw the dot at pi over 2. My coordinate is 1. All right, let's continue. Next, I have pi. Let's look at pi. At pi, my y-coordinate is 0. All righty, let's plot it. Next, I have, 3 pi over 2. Perfect, perfect. My y-coordinate is -1. Feel like I am not using the right color. I'm using blue, aren't I? That's fine. Blue, green. We'll change up the colors. Okay. And finish this up with 2 pi. Well, 2 pi is the same thing as 0. Well, we're at 0 at 2 pi. Boom. There we go. Right, now I'll pick the right color. And I'm going to connect it. Oh no! We're just going to use our imaginations and pretend that I did this much nicer. I'm going to draw an arrow on both ends because just like a circle can keep going round and round and round, the sine of theta, whatever it may be, is going to keep going. It's going to keep going to the right, and it's going to keep going to the left. Imagine it as the circle keeps spinning, the sine keeps going. All right? All right. Now, let's take a look at cosine. Cosine, on the other hand, is the x-coordinate. I don't think I should use yellow because that won't come out right, so I am just going to use orange. All right. So, orange for our x's. Let's begin at 0. I'm going to draw on that 0. There it is. At 0 radians, what is my x-coordinate? It's 1. Okay, well, let's plot it. Is this pink? There's the orange. I got it. Boom. Ooh, I even got the right little dot tool. Awesome. Okay, pi over 2, 0 is the x-coordinate. At pi, -1. At 3 pi over 2, 0. And at 2 pi, we're back over here at 1. Okay, this one is not the most prettiest looking, or at least not when I try it. Okay, just bear with me. Oh no. Oh, that's not pretty. That's fine. There we go. Make up the cute little arrows. Oh dear. Okay, I tried my best, but just like sine, cosine can go on forever in either direction. Just like the circle could keep spinning forwards and backwards. Here's a better picture of those graphs. Oh my goodness. Here they are, sine and cosine. Couple of things to notice here. Sine starts like at this point, goes up, goes down, goes back up. And I didn't want to say 0 because sine can get moved around. Cosine, however, it starts at an up position, goes all the way down, and then all the way back up. That's a couple of things to notice to compare and contrast on these graphs. In class, we got into a little bit deeper discussion about that, but let me know if you have questions about it. All right. Now, another word for a cycle of this sine and cosine graph, or I guess of this sine and cosine graph, since these are both sines, is called a period. The period is that length of the cycle length of the wave. And that is what I was trying to say without using the word cycle or period by saying it starts here, goes up, goes down, and ends. So check these two out. In this equation, we have sine of theta over 2. This one looks like it's way wider. I mean, yeah, it still starts at 0, just like the regular sine graph, but it goes all the way to 4 pi. Once it finishes, it's going up, going down, and then going back up again. And this, f of theta is sine of 2 theta. It got way narrower. Check it out. It goes, so we're looking at that same cycle, that same period, where we start at a point, we go up, go down, and then back up. So here, my cycle, my period, would start here, and then right there. So instead of going wide, so going from 0 to 4 pi, this one got super narrow and started at 0 and went to pi. And we'll talk about the insides of our functions and what happens when we change that up later, but this is still something I wanted you to notice. We can widen it and narrow it. Well, let's check these two graphs out and take a look at their possible periods. Okay, this one starts at 1, so that kind of looks more like my cosine graph. Starts at 1, goes down, and then goes back up. So let's see how that looks like here. Let me grab a marker to trace over with it. There we go. All right, let's start my cycle. I start it here at 1, I go down, and then back up. All right, I don't want to repeat myself. That's just one cycle, one period of it. I went from 0 to pi. So in this case, my period is pi. That's the length. All right, let's do this one as well. This one starts down here. It starts at 1, but then it does go up, down, and up. So this kind of looks more like a sine graph. Shifted up a little bit, but it's doing that kind of shape. So let's trace the shape and see the period of our function. So I go up, I go down, and back up again, and that's a whole cycle. That's it. That period is over. Started at 0, And I ended at, oh, I colored over it and I cannot see. Pi over 2. I hope that was helpful. If you have any questions, please let me know. Have a wonderful rest of whatever day it is for you. Bye.